Good morning. My name is Dr. Melanizer, and I'm going to introduce you to forces. Forces are the scientific property of changing things in the world around us, changing the speeds, changing the velocities. At this point, we've talked about speed and acceleration. Speed is the rate that something is moving at a distance over time. It can be moving not at all, or it can be moving at a set number of meters per second or miles per hour. Speed is just the change of distance over time. Now, acceleration was changing of speed. Acceleration is speeding up, going faster, or slowing down, coming to a stop, or changing directions. That's speed and acceleration. We're going to add one more property today, and that's mass. Mass is the property of matter that gives it weight. Mass is that resistance, that pull towards the Earth. It's actually made up of the protons and neutrons inside of atoms. Now, they can be configured in a different way. That's why you can have some big objects weigh very little and some little objects weigh a whole lot. Mass has a property, though, and that property is called inertia. Inertia is the resistance of mass to be moved or to change its motion. The best example everyone's experienced is a shopping cart. At the beginning of going to the store, pushing that shopping cart, it's really easy. However, as you start loading more and more and more groceries, the cart gets heavier and it's harder to get started and harder to bring to a stop. For the same reason, it's easier for cars to come to a stop than semi-trucks. Or it's easier to pick up a 3-year-old cousin than to pick up the 30-year-old 300-pound cousin, because both are resisting the change in motion. Now, force is what we use to change that motion. Force can be a push or a pull from the muscles of your body. Force can be the push from your legs. Another example can be the push caused by the explosion of gasoline in an engine that pushes pistons that creates the motive force that moves cars forward. It can also be a pull from a magnet pulling on a piece of metal. All of these things are examples of force. Now, momentum is the property of things moving at a certain speed based on their weight. And this is why, 3, 2, 1. This is why football players running into each other have so much energy, smashing into one another, because they're really big, heavy guys and they're impacting each other. Momentum is also the reason that cars, even if they're going very, very slowly, when they bump into something, they do a lot of damage because they're so massive. Whereas small objects, such as a Little League football team running into you, is a lot less threatening than a football player running into you. If you're bumped by a shopping cart, it won't hurt you, but if you're bumped by a car, it will. Those are properties of momentum. Now, Newton's first law is the law that states that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an outside force. I usually think of this as the toddler in the house unattended rule. If something gets broken, it's because someone did something. Now, things don't move until a force acts upon them. The lamp doesn't fall over unless something touches it. By the same token, objects will continue to stay in motion until acted upon outside force. Inside of our atmosphere, there's lots of things to act on you. But in space, the reason that the Earth keeps going around the sun and the moon keeps going around the Earth is because objects in motion will stay in motion unless something impacts them, like a meteor. Newton's second law states that force is equal to mass multiplied by acceleration, or you need more force to move heavy things than small things. This is why if you are trying to push a shopping cart, it's very easy. If you are trying to push a dead car, it's very hard. Why? The shopping cart weighs a whole lot less than the car. So the same amount of force can cause the car to move slowly or the shopping cart to go really, really fast. Newton's third law says for every action, there is an equal and opposite reaction. For every time you push something, something will push back against you. Every time you pull something, it will pull back against you. Some examples are when you open up a balloon and cause the air to start rushing out, the balloon is going to be going in one direction as the air is going out the other. If you put an object in your hands and lift it up, the gravity of the object is pulling down on your hand, but your muscles are pushing back up. You can feel it because it's pushing down in your hand, and you are pushing back on the object. In the case of people when they're hunting and they're firing a gun, the gun causes a bullet to go forward while the gun impacts back because of the explosion in the cartridge. That is Newton's third law. Any questions? Here are emails. Thank you very much for your attention.